So it's a very long process. So we started this new project called IMD 2030. It's a 10-year project. I think we are in 2020, well, 5 now. So 5 years is gone before we even realized it. So the next 5 years is going to be a very intense exercise, culminating in the definition of 6G, and then maybe 2032 to 2035 time frame, you will see 6G products. At the time 4G will sunset, but you will have 5G plus 6G. This is how the world keeps moving as a continuous evolution. Okay, so India as a country didn't have a history of influencing these technologies till about 2015, the year 2015. The reason is that, well, that's just historic. We just didn't do it as a country. In 2015 onwards, we had developed a group called Telecom Standards Development Society in India, and this society is backed by the government, and its responsibility is to deliver these standards and work with the ITU. And another group called 3GPP. That's another program where actually companies and industry develop these so-called specifications. It's a joint program between 7 regions, including United States, European region, Japan, China, India, Korea. Their member SDO, Standard Development Organizations, run a joint project called the GPP, where you develop these specifications. And these outcomes are taken and sent to ITU by member states, and they get ratified. And once they get ratified, you have these standards. So these standards are truly global standards with inputs from many different countries, and the companies belonging to these different countries, they actually send scientists and engineers. They meet once in a month, and they sit together and write these specifications, and they become these standards. This is the background scene, how these standards get developed. So now let's turn our attention back to 6G. The vision document or the framework document is like a foundation for a house. Okay, so you need to have the basic foundation and the architecture, and this picture is the fundamental architecture for 6G. So if you want something new outside of this, you will not have it. So on day one, you have to go there and get your wish list. You are building a house, you have to tell the architect, I need these things. And this is the picture, this is the blueprint. So to get to this blueprint, it's a 2 years of work between the member states. Of course, their respective companies and universities that came up with this blueprint. So let me spend some time on this because it influences pretty much whatever devices we use going forward in the future. Just like the way the cell phones that you carry had a similar blueprint a decade ago. The middle portion is the triangle is actually 5G. Okay, it has 3 parts to it. EMBB stands for Enhanced Mobile Broadband, basically smartphone services. Then there is a corner called Massive Machine Type Communication. In a simple word, they are called IoT devices. IoT devices, not Bluetooth and Wi-Fi, that's a different family altogether, but IoT devices that connect directly to cell towers. There are few of them out there, like cameras with the 4G. They're called dongles in popular terminology. Dongles and IoT devices. You can connect cameras, water meters, electricity meters, gas meters, asset trackers. They're all called IoT devices. And the ITU name is Massive Machine Type Communication. There's something on the right side. It's called Ultra Reliable Low Latency Communication. There was a big wish list that, they will connect all robots and factories with wireless and with a latency on the order of millisecond or sub-millisecond, and will automate industrial settings. Actually, it never happened, so that's a pipe dream, so it won't happen probably for a long time. That's because industries, especially in process control, they love wires, and they just want to send their information to a wire, which gives you a guarantee to deliver your bit in a prescribed time. So wireless is a difficult proposition for factories and automation. So we have a long way to go, just reliability issues. Now what is 6G? We only have 3 vertices of a triangle in 5G. These 3 vertices are 3 different services, of which 2 are a reality today. We'll continue to enjoy those benefits in the next few years and maybe over the next decade of those services. Better speed, more reliable connections, more IoT devices. It's in infancy, but they'll continue to grow. But this 6G has a new shape. You see this polygon here with the different vertices. 6G has ballooned this vision with so many new services, which are called usage scenarios in IT terminology. I'll spend some time on this. I can talk the whole day, but I'll take 5 minutes on these new usage scenarios because this is the crux of 6G. Enhanced mobile broadband, you see that, and there's an arrow upwards, is evolving towards something called immersive communication. What is immersive communication? For a layman, it is something like just not a smartphone, but something else. That something else is AR, VR, XR kind of services. They're not there yet. Maybe, hopefully, they'll be there 10 years from now, 20 years from now. Hopefully, making a difference and impact in our lives. Okay, not just for entertainment, by the way. It's for something else. Like you can get your, you can prepare your own, you can do your own plumbing work, putting a XR headset and somebody instructs you. So you don't have to have a plumber at home. This is just one possibility in the future. Or today, AR/VR device is used in the medical colleges to teach students how to practice on a body that doesn't exist. People do that. So new things are bound to happen, but 6G will deliver so-called immersive experience. Why it is important? It just requires a lot more speed. The phone today gives you maybe 3 megabits per second when you move around, but this requires maybe 50 megabits per second, maybe 100 to get true immersive experience. So this is a long way to go, but that's part of the deliverable for 6G. Then on the bottom, something new is introduced, and that was a huge debate and contention. This was introduced by my own group, along with contributions from the government and industry, something called ubiquitous connectivity. So naturally, a country like India introducing something new in this picture is frowned upon, at least to begin with. And there was a lot of fights, and finally, you will be surprised to know a compromise was struck at the highest levels of India and US between the respective administrations. And we introduced something called ubiquitous connectivity. What this means is that you should have communication anywhere, anytime, where people live. So in other words, we're not asking for communication anywhere, anytime in unpopulated areas. That's not the meaning. It is terrestrial communication where there are people. They should have an ability to communicate with mobile broadband experience. So it turns out that we have not fulfilled that goal as yet. If you just go 50 kilometers or 100 kilometers from this place, you'll see a vastly different experience in the villages around. So there are numerous reasons why it is so, but you may say why 6G has to deliver it, unless it is codified as an ITU vision framework requirement. It doesn't trickle down into the other layers like technology, rollout, obligations, and all that. So there was a lot of fight, and we got this through. That's why you have an India flag there. It's a new thing. Then there are 2 new things. Actually, there are 3 new things. One of which is ubiquitous connectivity, and there are 2 other blue color items. They are also new. One is called integrated sensing and communication. It's totally new. What does this really mean? It means 2 things. From a cell tower equipment point of view, it should have an ability to act as a sensor. Sensor in the sense, more so as a radar. So one straightforward application is the base station can localize objects by acting as a radar. And that's something that's doable using 5G technology. Although you may think that why radars are required, uh, maybe you can put this in the border areas, the same dual purpose equipment, and you can identify objects that are flying around that you don't want. Typically 5 kilometers using the 5G class of equipment. That's one application. There are others, the long list of other things. The other part is this artificial intelligence has somehow creeped into communication in some way. We can have a long discussion about why it has come in here into communication, but it's part of the vision and vision document, and there are some requirements associated with AI being a part and parcel of 6G. How? We can have a long discussion around that, maybe in the Q&A session. Okay? These blue items are new. They didn't exist in 5G, and the other items, the other 3 green color items are an expansion of what exists in 5G. Okay? And then on the top, you see connecting the unconnected. Okay? ITU work in different ways. This group is responsible for terrestrial communication. So 6G belongs to this group called Working Party 5D. But actually there is something called satellite. And I think you all know, very soon you should be able to spend 10,000 rupees, make an order, and Starlink will send you a box. You open the box, you put it on your roof or somewhere, and it will point to the sky, and you get about 5 megabit per second speed through Wi-Fi. Then you just wire it down into your home, and if your home is in a no man's land, then you will have connectivity. So this is connectivity anywhere, anytime, where people do not necessarily live there. You can go build a house anywhere, or just go take a truck, have a picnic, and set up your connection. I have done this and it works. Okay, I've personally tried this. So India is going to have this hopefully very soon. So connecting the unconnected is total, true connectivity anytime, anywhere, including Himalayas and in the middle of the ocean. Okay, that's going to be a reality, but it's called a complementary technology. So what is 6G? It's not a part and parcel of 6G, but it's a companion to 6G. 6G is terrestrial communication, and satellite is a part of it. This includes high altitude platforms, airships. Airships will come soon, at least in Japan they're coming soon. You can have one ship cover, I think 3 ships can cover the whole island of Japan, probably, I don't know. But India needs, I think, maybe 10 ships. They fly at a different altitude, they're between here and LEO orbits. LEO is constellations are a reality, including GEO. Okay? So satellite is a part and parcel of communication very soon. And I don't know if you have used, but some of your cell phones have an ability to connect to satellites, especially when you go away from Sangareddy and you get stuck, you can send an SOS message. I think Apple phones support that, maybe starting next few months in India. I think in the US it's already launched. Even Android devices will have that. Okay, so I don't want to get into these totally scientific aspects of the so-called capabilities of IMT 2030, but some of you are computer science background. Just look at the blue colors. They are new. The green actually existed in 5G. Okay, the blue color is new. There is something called interoperability. This is new. Systems are going to be interoperable. Wireless systems are going to be interoperable in the sense that the base stations, the equipment is not going to be monolithic. The radios, baseband cards, core networks, they'll all become interoperable. Different vendors can manufacture them, and you can plug and play. In fact, there's one such system in this campus. If you're interested, I can show you at the end of this talk. There is sustainability. There's a lot of focus on reducing the energy consumption. The energy consumed per bit has to go down. People need to work on that because as you keep increasing the number of bits flowing through the devices, you have to keep the energy consumption down somehow. So there is a great emphasis on energy consumption, both mobile devices as well as network. network components. There are AI-related capabilities, still a work in progress. There are sensing-related capabilities, and we introduced something called coverage. You'll be surprised to know, for those who hold cell phones and devices, you think that getting coverage is your right. Of course, it is your fundamental right, but actually ITU never recognized that as a fundamental right. They just kind of washed under the carpet. For 50 years, they refused to write this coverage as a metric that the administrations have to meet. And we actually introduced this from India, and there was a lot of fight around that. So there are two things India introduced: interoperability, that is openness between open interfaces between different network elements. Open RAN is an example of that, and coverage. These two are some things that came from India. And you have these all other things. Latency will continues to go down. Somebody demanded 100 microseconds latency. I think this request came from Japan. It's very interesting to know why. Today's systems don't even offer 1 millisecond latency, although 5G promised that. The high-speed trains are supposed to do reliable communication at 500 kilometers per hour. It can be done through 5G, and that continues to be the case. Maybe you can have you can support devices moving at 1,000 kilometers per hour. I don't know what they are. Maybe aircraft taking off, still connecting to the ground. And a whole lot of other things that you see on the screen. Reliability continues to improve as far as the specifications are concerned. You can have hyper low latency and really reliable communication as long as one can find those applications. They don't exist as of today. So this is what the capabilities of 6Gs are. And as far as the applications are concerned, you can just go over it, take a moment to see what this means for the society in general. As far as the vision, ITU vision document is concerned, and the technology and the capabilities are constructed to meet these envisaged societal applications. There is something called ubiquitous intelligence. You can see that. There is ubiquitous computing, immersiveness, multisensory interactions, the digital twin. Health is a big thing, ubiquitous connectivity, sensing, communication, sustainability. These are very important things. The whole framework is designed around that. We'll move on. Okay. I talked about this. By 2030, this has to happen. So there is a very detailed plan around that. It's the activity started very actively in this, the previous year, and this year is going to be a lot of action. So what is India's role in all this? So interestingly, we did back-of-the-envelope calculations. In the previous generation in 5G, of all the scientific papers submitted to the standards bodies, India's output is less than 1% of the whole. Well, that's still a good news. 1% is a very large number compared to zero, because for the previous several decades it was an absolute zero. So 1% was a quantum jump, and not only it was a jump, you got a seat at the table, and we can dictate the terms in certain way that you have seen in the vision document, how we made our presence mandatory. So the vision, there is also the Prime Minister's document that was released in 2023 called Bharat India 6G Vision. It aims to take this 1 to 10% of the global share. That's going to be a tough goal to achieve because you need to put as much money. So to get 10% of the share, you probably have to put in $1 billion in R&D. We have not done that yet. Okay, so everything goes back to money, and we don't have such teams in place to go from. We're not even at 1. We're probably at 1/3 of a percentage. So you are aiming for a 30-fold increase over a decade, that's really difficult. So you have to pump in a lot of money, and there's not nearly adequate enough talent and engineering skill available to do that in India. So hopefully some of you will join this mission. That's where it is. A lot of work to be done. I will spend, I think, a few minutes on the technology aspects of it. It's very deep tech, but I'll try to not get into there are no equations, that's the good news. Okay? So I'm going to take one small dot from that vision document. There are 3 new things and 3 old things in that polygon. And one of the new things is ubiquitous connectivity. So actually when we introduced this, a lot of people had a lot of unhappiness when somebody from this part of the world introduced something so big. Okay? So how do you achieve ubiquitous connectivity? This ubiquitous connectivity is not English dictionary definition of ubiquitous connectivity. It's not. It is ubiquitous connectivity that is very high speed, reliable communication where people live. Okay? That's what is ubiquitousness here means. Okay? Where people don't live, I think Elon Musk has solved this problem to an extent, and we have to follow suit, launch our own systems. Okay? So we have 4 components to this ubiquitous connectivity package that we have constructed at IIT Hyderabad. We've been doing this for well over a decade, working on these things, and some of these are already part and parcel of 5G. Some of the solutions, the phones you use, the network you use includes some of the inventions made from this campus are part of 5G. And we are doing the next generation version of that in a package called ubiquitous connectivity. So to that goal, we introduced a new waveform that actually solves some of the nagging problems that we had for more than 2 decades in wireless. That is, there's a waveform called orthogonal frequency division multiplexing, OFDM. It's very much loved by a lot of engineers, and it's the waveform that's powering your 5G connections as well as 4G as well as Wi-Fi. So as much as people love this, it has one drawback. We somehow ignored it and lived with it. It's not energy efficient. That is actually the amount of power the energy the battery power that you feed to the device, actually about 20% or 30% gets transmitted over the air in the electromagnetic wave. The rest is dissipated as heat. So it's totally energy inefficient. It is just there are their own scientific reasons behind this. This waveform is not energy friendly or power friendly. And linked to that, and to put a lot of power out, obviously, you have to feed enough energy to get the signals out and travel further distances. There's a cost to it, not just the energy cost, but the devices themselves. There's something called power amplifiers. They constitute 40% of the cost of the entire system. 40% is a big number. And the more power you want, the price goes up exponentially. Okay? So Wi-Fi devices, they're low power devices, so everything is okay. But as you keep increasing the transmission power, the cost of the power amplifier, it just increases dramatically. But of course, then we have friends in the semiconductor field. They just try to bring down that cost. They create new semiconductor processors, new technologies to make them more energy efficient. This keeps going on and on and on. But fundamentally, if you have a new waveform that is more energy friendly and still achieve and meet all the intended goals, you're better off using that. And we kind of solved that problem. In fact, we built a prototype that will be demonstrated in the next few months in this campus. The second part of it is the frequency spectrum. Electromagnetic spectrum is is a precious natural resource, especially in frequency range between 600 megahertz to about 7 gigahertz or 6 gigahertz. This range is very useful for terrestrial communication. And this spectrum is limited and it's very expensive. So one piece of spectrum costs you about $10 million if you have to go buy it in an auction. So the only way to solve this problem is use massive number of antennas, and these antennas create bandwidth. And we have shown that. We had an experiment running in this campus for about 11 years. We just shut it down. I'm done. So it is shown that actually you can mine as much bandwidth as you want by increasing the footprint of the antennas. So I'll skip through all the technical details, but I'll just show you this picture. I think some of you can recognize this. We have this huge antenna array, and we showed a spectral efficiency of 110 bits per second per hertz. And today's technology stands at about, I think, 8 bits per second per hertz in 4G, and 25 bits per second per hertz in 5G, which is a big leap forward. And we achieved 110 bits per second per hertz through real experiments. So of course you can see that the penalty there is a massive amount of hardware. Of course, we've miniaturized that, and lots of antennas. So the antenna footprint increases, but spectrum can always be mined using these antennas. And we're going to push forward this discoveries into 6G in one form or the other. I will summarize. 6G is going to, specification will come in 2030, the systems will get rolled out in probably in 2035. 5G has still a long way to go, maybe another 5 years before it becomes fairly stable and available for most of us. And we continue to work on these technologies. They are important. Various reasons, technology ownership is very much critical, especially for a country like India who aims to grow up this ladder. You need to be a significant player of intellectual property owner and technology ownership, and so on and so forth. We are making small efforts in this journey. Thank you very much.
Yeah, let's take a couple of questions maybe. Questions?
Thank you so much for this informative talk. So I'm pretty much curious, right, because we did not talk about AI/ML till 4G and 5G. Suddenly AI/ML becoming a prominent part of 6G, right? Okay, so my concern is like how successful it is going to be, because if it was so much enthusiastic, why didn't we talk in 4G or 5G, right? Suddenly all boom is coming at AI/ML part. So what's your thought?
Okay, thank you. That's an interesting question. I had given a very long answer to this in some other talk. You can go to my talk at Hudson, and you will see 1 hour talk and 10 minutes Q&A, but I'll briefly be from that. The introduction of ChatGPT happened only recently, and it has solved some new problems that we thought were not possible. They're not solvable. Vision and speech and language are practically solved now. There are many other. I don't have to talk about AML. In communication, one place where this will be used is for network automation. That is, you have millions of cell sites, and you have a lot of data coming in, and a simple example is you have all this massive data coming in. Okay, this is down, this is up, this is the faults, the performance. This site has low speed, this site coverage. All this can be managed at a network level using GPT-like tools. Okay, or maybe you have to create your own fundamental algorithms. This for network automation. This is going to happen. Maybe 5-10 years. The other AML that we talk about is not is about the fundamental wireless communication. So people have created channel codes, channel estimation algorithms, and all that. But that's not really interesting because that's esoteric stuff. Because systems operate at Shannon's limit, so there's not much interest. It's very interesting for a student and intellectual pursuit, but for practical considerations, it's just yet another tool. Okay, it's basically signal processing, and what is done in communication is also signal processing and channel coding. But that's not important. The important part is the devices will use communication, and the devices will also use machine learning for other purposes. There will be agents, there will be there is sensor inputs, and all these machine learning algorithms will run on this device that also has communication in it. Although you may think that they are really separate aspects, but if there is one application that uses machine learning that places a huge demand on the data pipe, let's say 10 Mbps or 5 Mbps, then if that happens, it's not the case now, then the whole communication industry has to support those needs. So there's a lot going on. In some parts they're loosely coupled, in other parts it is being used for network optimization. For some people, they really want to design the whole communication link using AI algorithms. That's just esoteric stuff. Sorry.
We can take one. I will do later. Okay, let's do that later.
Okay, thank you.
Let us thank you. Okay, our next speaker is Dr. Dilip Krishnaswamy. So, Dr. Krishnaswamy, please come forward and set it up while I can go ahead and introduce you. So, Dr. Krishnaswamy is the director for CDOT, and he has led the architecture, design, and development of engineering platform and products at Intel Corporation, Qualcomm Research, IBM Research, and Geo Platforms. He received his PhD degree in electrical engineering from University of Illinois at Urbana-Champaign. He is an inventor of 70 plus granted US patents and has authored 70 plus research publications. He is presently serving as the director for CDOT, Center for Development of Telematics, in Bangalore in India, where he is leading the advanced 5G engineering and 6G innovation efforts. So Dr. Krishnaswamy is going to talk about the potential research and emerging research direction for 6G communication.
Thanks for the introduction. So Kiran gave a very beautiful introduction about what's happening with 6G, and so hopefully I will be complementing the talk with additional topics, particularly related to emerging technologies and what's happening overall from a network side, and also bringing in AI, quantum, and those aspects. So, there is a very keen interest in India at this time to really engage in the telecom sector. As Kiran was saying, so far we had not engaged much, but Prime Minister is really keen that we should engage. So I would encourage all the students here to actually take advantage of this time where India is actually leapfrog. How much time do I have? cover some of the key areas that we could focus on. There's a lot of interest, as I was saying, and I'll give some pointers as to where, if you guys want to become entrepreneurship and take the entrepreneurship route in your lives, how you can pursue that opportunity. Though I must tell you, Kiran has been at it for 10 years now to get to where he is. So especially from the hardware side, it can take a long time. From the software side, you can develop technologies faster probably. So you have to choose where your passion is. You've seen these slides, so essentially all the different vectors that are being targeted, and Bharat 6G has a vision to actually pursue all of these vectors, especially ubiquitous connectivity and coverage for all of India. No matter, you want to get a wireless signal, no matter where a person lives in India. That's the goal. And sometimes when you have these operators, they think about, oh, are there enough people near this tower? And should I put up a tower? And somehow we have to remove those barriers and still reach everybody. So some of the key directions that India can focus on is like coverage for rural and hilly regions, and some of the areas are reconfigurable intelligence services, and non-terrestrial networking systems, which are more like satellite-based communications or high-altitude platform systems. Also, a lot of different networking technologies, heterogeneous intelligent networking is going to become important. Digital twins will play a huge role. AI-enabled networking will be very important. Sustainable systems as well, and quantum-inspired processing. And with this, with the emerging networks that we have, we'll also have programmability and observation and control. We'll be observing continuously. We have automated agents processing it, and then also taking decisions in an automated manner. So you have complete closed-loop automation with this programmable networking, and that'll make a big difference going forward. And it's also very important to have this, especially with the heterogeneity that is there. So, additional areas are that, hey, you have, what's going on now is like, say we had, if you think of the Wi-Fi access point, you have the access point and then quickly you're onto the internet. I don't know how many of you have seen a cellular stack. There's a radio access network and then a core network, and then you get into the internet. And in the radio access network, you have all these base stations, and they're all connected to each other. There's mobility being handled and all of that. And then after that, you have upper layer software in the core network managing authorization of users and security and things like that, and managing sessions, allocating resources, and so on. Now, within the radio access network, what was a base station now has gotten fragmented into what's a radio unit, a distributed unit, and a central unit. So the radio, and there's a reason for this. As people started exploring different frequencies for communication, and as they went into, say, millimeter wave and things like that, the range started reducing. So you have to get the radio unit closer to the people to serve them. But then the rest of the processing could be further away, because the rest of the stack is in software, and that can sit somewhere else and send data to the radio unit. So now you have the distribute unit managing multiple radio units sitting further away, and the central unit that could manage multiple distributed units could be even further away, or it could be combined and so on. So you have options. So now you have a distributed system. Even on the core network side, with 5G itself, a lot of functions got different network functions got created and virtualized. So there's all these resources. A lot of it is in software, and the lower level stuff is hardware and wireless. So there's a lot to optimize dynamically in these systems. So distributed system optimization is important. Semantic communications, we'll talk about it. Zero trust. NIST is enforcing zero trust-based processing, where you want dynamic security, in your system. You don't want to just authorize and just let an agent do whatever it does. Continuously monitor the agent, see its behavior, and then act. And then we can explore new waveforms, scheduling techniques, new communication channels. FR3 is between FR1 and FR2. I'm not sure if you know FR1 and FR2. FR1 is like up to 6 gigahertz. FR is frequency range. Frequency range 2 is say about 25 gigahertz. FR3 is like in between them. And then sub-terahertz as well, going up to like 300 gigahertz. But sub-terahertz will be more like local Bluetooth-like communications, very high speed. Like I said, as the frequency goes up, the range comes down. But it may be very useful for these use cases where you have augmented reality, or maybe you're transmitting a hologram of yourself across somewhere else, and you have a digital optical pipe, but you're locally, 3 of you are in a conference room, and the information is getting aggregated in a sub-terahertz network. Distributed intelligence sensing and dynamic control and robotics would become important, and also space research would be very important for us to get into. With new satellite configurations, potentially we can look for what satellite configurations can provide coverage for India at minimal cost while covering India, not worrying about the rest of the world, kind of thing. So, and we could work with ISRO for that. So one of the technologies that we demonstrated at the India Mobile Congress is a reconfigurable intelligence surface. The goal is like, okay, there's a hill, there are people living on the other side of the hill, and there's a tower on, say, this side, and the signal is being blocked by the hill. Maybe it's easier to put a fiber down here and set up a tower and communications, but it's maybe much more harder to get it to the other side. So one thing that you could do is put a reconfigurable surface, a reflecting surface on top of the hill that can actually send a signal to the other side. And then you can actually distribute the signal and share it with the users there. And so we're working on this technology, and it's very promising, and hopefully we can serve people in hilly regions in Northeast India and so on. Also, going forward, we'll also have not only like 4G, 5G, Wi-Fi networks, or 6G nodes with RIS and services and all of that. Also non-terrestrial networks, satellite-based configurations. And as I was talking about this closed-loop automation, where we are observing information from all of these different technologies, and then we are deciding, hey, which access technology might be best to serve which set of users and things like that. These can be very interesting problems for you to formulate, and solve, in an Icdcn conference publication kind of thing, to bring in this heterogeneity and dynamic learning and optimization. So what happens is you would have, in these networks, you will observe the data, and then it goes up into a service management and orchestration layer where information is coming in, and then there's a intelligent controller. This RIC is called a RAN intelligent controller. And there you can look at the data and then decide to take some action if needed. And you could be using AI, ML, and quantum accelerators. And then from here, you actually have, you not only have observation, but you also have control back on these devices. So you can reconfigure the systems. And then you can have these intelligent controllers at different levels of latency. You can close the loop at lower latencies or higher latencies and so on. And this is a disaggregated RAM that I was talking about. What used to be an access point is now split into a radio unit, a distributed unit, and CU. For example, if you have in a base station, if you have three sectors, you can say there are three radio units pointing, say, 120 degrees apart. And then a DU can be serving those three RUs. And then there could be, say, 10 DUs being managed by a CU kind of system. So this would be interesting. Now, AI/ML comes in many different dimensions. And let's see how much time we have. 20 minutes. Okay. So as information comes in, as I was saying, from the networks, you can be learning the network model. You can be learning it offline. The learn model, you can put it into an inferencing engine live in the network. And as you learn, you can say, hey, I'm reaching saturation in the network. I need to increase capacity. For example, you may have in a particular location, you may be able to transmit at 2 different frequencies, but you may choose not to transmit at, say, frequency F2 if there aren't enough users. But if, as the number of users start increasing, then you will turn on, and so you will expend more energy. And then as the number of users come down, you can turn it off. So think of this happening in a mall. Like you would increase the capacity. So F2 you will say is a capacity cell, and F1 will always be there providing coverage. Normally F1 will be at the lower frequency. It has a higher range. It's providing coverage. F2 will be in the mall or in an enterprise or something like that. So to increase capacity. So coverage cells, capacity cells. You can be learning as the usage goes on. You'll start predicting, hey, I need to turn the cell on, or I need to turn it off. So you will send it to an intelligent algorithm here that will take a decision and then reconfigure the network back. And and the agent here can be doing some dynamic processing. It could be AI/ML based, quantum based as well. Here we have a digital twin based model, but there are 2 types of digital twins. One for design, where you will try to build these models as you try to build the algorithm there. You still haven't deployed it. But when you deploy it in the network, you may have to refine the model, you may have to fine-tune it further. So that becomes a digital twin for operations. In operations, it gets fine-tuned and further refined and plugged back into the network. Now, transformers are everywhere with us. And it's a beautiful thing, and with self-attention, you have an input in, say, D dimensions, and the output can also be in D dimensions. You can change the output dimension to be something else as well when you do the final dot product. But the same input is utilized as the key, the query, and the value, as you know. And but if you just did the dot products with just those vectors, it becomes very straightforward processing in terms of, hey, the output of the encoder, which is going into some embedded latent space, is just directly a dot product of the vectors. But what we do is we transform the vector with weight vectors, and so then weight matrices. So then the queries values become sort of programmable with the weights that can be learned, and you can have different attention heads to learn different weights to capture different types of inputs and then provide an output. And then so each attention head produces an output, say, of dimension D. You would concatenate all of that and across multiple attention heads and then try to create an output. So essentially, data goes into a latent embedded space. Things that are similar to each other stay close to each other. Attention circuitry triggers across the information that's there and then produces output. We can use this. So typically this has been used for natural language processing, right? ChatGPT kind of thing. We're actually using it for time series modeling, and we demonstrated this as well at India Mobile Congress. So these are network KPIs that are coming. There's a time series coming as a function of time, enters into a latent space, and then we can predict what the future values are. And so, here's an example of KPI data for like a single cell of operation. Here, this is what I'm saying, like, the 15 minutes. So there's a metric called PRB utilization, physical resource block utilization in communications. And you can see this, if I just had the coverage cell on, it's already hitting 100% here. And this is like during the day, at 8 o'clock, a lot of people are on the road, or say at 5 p.m., a lot of people are on the road. And so you get these camel humps, during the day and multiple times of the day. Sometimes you also get it at night because people are Netflixing at night. So you get 3 humps, 3 camel humps. So, and this is over 3 days here. And so you have this kind of repeatable pattern. And here it's hitting saturation, so capacity is not enough. So if you turn on another cell, now the PRB utilization, and you share it across the 2 cells, now the PRB utilization is nicely distributed at 70% across all of them. There's another metric called accessibility. You want it to be close to 100%. And here, accessibility was dropping to 94%. So that means a lot of users were not getting access to the network. There's another metric called retainability. That is, you get access, but then you're immediately dropped because the other user is trying to get in. So, and you want these kinds of metrics like accessibility, retainability to be close to 100 and so on. So you try to take a decision in a closed-loop automation manner to turn on the cell dynamically as you observe an increase in capacity. Maybe there's an accident on the freeway, and you have to do this. We've used LLMs. We have time series modeling, and you can see with the LLMs you're able to actually predict the future usage. Essentially, though, what was the word in for ChatGPT, for our time series LLM, the word is actually a range of numbers. So and one number predicts the next number and the next number and so on. And attention heads capture the jumps at 8 o'clock or 5 p.m. and things like that. And so it's working beautifully. So and based on this, and you can have anomalies like maybe there's an IPL game and then that creates another surge of usage, and that can be actually modeled as well. So and then based on that, based on what you're predicting, now you can see further ahead. If you just have typical time series predictions, you might just see a short time in front. But with this LLM, you have a large window of output that comes out, which you can change as you program how much you want to see further ahead in time. And based on that, you can plan well in terms of how to optimize the network usage. And here you can see we were able to kind of turn off cells when it was not required. And I think about 27% energy savings was obtained. Normally, half the cells would have to be on the coverage cells, and then if you turn on all the cells, it would be 100%. If you had only the coverage cells, then you would not be able to serve a lot of users. If you just blindly turn everything on, it would be 100% usage. But at 72% usage, everybody is being served well at all times. So your baseline is 50%, and then is at times when you need to, you go to 100%. And then semantic AI processing is also interesting with these kinds of processing. Essentially, if you have a vector database at the input and a vector database at the output, you can, it's like, let's say you go to Wikipedia and ask a query about, hey, tell me what's about genome sequencing, and then there's a lot of information that you get. Maybe you want to send that entire information to somebody. Instead, you would send the Wikipedia link, right? That's the query that you would send. So, similarly, here, you just send the query to that vector database and send it across. And if the vector database matches, you recover the information. And this can give you significant amount of compression in the network. Now, semantic, they also say this is semantic because in some cases, you may not need exact reproduction of information as long as the meaning is conveyed. So there can be use cases where, as long as you've conveyed the information to a large degree, you're fine. And there are use cases where you can do that. And so this is becoming very important and can be definitely a good area for research for a PhD thesis. Sustainability is also important. So I've done some work here on sustainable AI processing, but essentially as you add more resources, let's say you have a 70 billion parameter model, maybe there's greater trust in that, but a lot more energy being consumed with that LLM. If you have a 7 billion parameter model, Llama 2, you may not trust it as much. But it takes less energy. Maybe the 13 billion parameter model takes a little more energy, maybe a little more trustworthy. So you have you can define a risk function as a function of the amount of resources you're allocating to the problem, and you can define it as an exponentially decaying function. There's ultimately some amount of risk regardless of what you do. Depending on the security and trust in the system. So B is like that asymptotic level of risk. A plus B is where you start. And then as you increase the number of resources from 7 billion to 13 billion to 70 billion, you start reducing the risk. So you can have risk functions like this. And similarly, you can have risk functions for security. You can, depending on the dimension that you're operating in, which elliptic curve, for example, can be more expensive to compute, but maybe more secure. So that your risk is reduced as you use more energy, more resources. But then if you have a finite amount of resources, then you have to figure out how much to allocate for different operations, whether it's AI or security and so on. And so you could think of an L2 norm of these risk functions. And maybe you're operating somewhere, and suddenly you have an additional amount of resources. How do you allocate that? And so you could do proportional allocation based on this, for example. Think about the risk and the change in the risk as well. And then effectively, if you do a steepest descent, this is what you get. And this gives about 72% for AI and say 28% for security, for example. And then coming to quantum, and 23. So I was actually watching a program, and this warning came at the start of the program. And essentially this is where quantum is right now, which is that, right now the quantum systems are error prone, the qubits are not stable. And so NSF has said, hey, let's go back to the physics and redesign these quantum systems. Google just came up with its Willow processor saying that, hey, as I increase the number of qubits, I can reduce the error in the system. So there's some promising stuff happening there. So quantum, we are not ready yet, but maybe in another 10 years, it's there, it'll come. So the physicists are at work right now to make better quantum systems. And in India, DRDO, TIFR, and TCS work together and built a 6-qubit quantum processor with superconducting circuit technology. So it's a great thing that we should celebrate. And from a quantum perspective, from a networking perspective, you can think of quantum-inspired processing where you have different states. For example, maybe there are 10 different access points and you have to choose which one to use. And depending on the load at each one of them, you may choose one which is less loaded than another and so on. So you could do some dynamic load optimization. As users come into the network, you would assign them to access points that are less loaded. So the wave function is the superposition of the states, and states can be which access point are you connected to. That will be SI of t. Alpha t is amplitude, which is the square root of the probability. That is kind of reflecting what's the likelihood of using that access point, for example. So you have all the options in SI of t and then a weighted combination as a wave function. So any problem where you have multiple states, and each of the states, you have a probability associated with them, you can describe it as a wave function. So even as we wait for the quantum computers, we can start doing quantum-inspired processing. And this is for PCI optimization. There's a graph coloring problem as well. Like SIs were all the different colors that you could assign to different nodes in the graph. And going forward, you can think about quantum coordination across axis nodes. Let's say there are m-axis nodes. As I was just saying, the wave function can be a weighted combination of that. It's a Hilbert space across the m-axis nodes. You can flip the problem. You can have multiple devices talking to one axis node, and then there's a Hilbert space B across the n devices that you're trying to connect to this axis node. And now there's this area called cell-free access. You have a whole bunch of access nodes that like the heterogeneous networking I was talking about. And so you actually have a composite system now, which is a tensor product of the two Hilbert spaces. And then you're trying to solve a problem across that. So we can think about these problems in a quantum-inspired manner, and we can do the research now. We don't have to wait for the quantum computers. And this is what wave function amplitudes may look like for 8 devices. So the 16 access nodes, and so on. The x-axis is all the 16 different access nodes, and the y-axis are the amplitudes of the square root of the probabilities. And lastly, coming back to AI though, AI is here, and so we will work on AI-enabled networks and systems. We can have hierarchical realizations of digital twins, and these network of digital twins can be combined to represent an overall network. We can have network sets of a set of transformers interacting with each other, representing different functions, and also think about optimization in these kinds of distributed systems that are AI-based. And additional research directions could be, AI processing in this distributed heterogeneous network, digital twins for design, digital twins for live operations, as I mentioned, zero trust, AI-based zero-energy network operations, trustworthy AI processing, energy optimal, explainable intelligence. Need not be AI-based. If there's an algorithm that you can actually write, with signal processing, then that may just be fine. And semantic AI-based processing as well will be very interesting to pursue. And for Bharat 6G for India, we can think about innovation based on emerging technologies to develop good solutions for people and help not only urban communities but also rural and edge communities, like those reconfigurable surfaces, for example, that I was talking about. Finally, for those entrepreneurs that are there, we have the Department of Telecommunications has created this website, and please go here periodically. You will see different call for proposals. Right now, the 5G Intelligent Village and the quantum related proposals were put out recently. But there's a lot of funding here, and so please watch out for this webpage and launch your company as you graduate. And hopefully get funding from the government. The government is really keen that all of us should do something innovative and hopefully make a difference to India as well. So, thank you.
Let us thank Dr. Any questions? Any questions from anyone?
country is still unconnected. At least half the country is still unconnected from a broadband perspective. Um, the government is trying to get optical fiber through the National Optical Fiber Network to all the gram panchayats. From there, they're now trying to send it to the villages. As it reached the gram panchayat, people were thinking about, hey, last mile connectivity through wireless, and from there, whether do you need a multi-hop relay or just a direct signal. One of the things that people have worked on is trying to reduce the modulation encoding scheme to a very low bit rate level that can reach much further, like 8 to 9 kilometers and things like that. Our gram panchayat serves about 4 villages and so on. So there you can see that, okay, you will get connectivity, but the data rate will be very low because of the wireless signaling. So the government is still trying to get the fiber as close to each village as possible, and that may take some more time. But really, we have to do that. But a lot of India is hilly, and so what can we do to cover hilly regions is the big question right now, and therefore we're looking at these reconfigurable intelligence services that can reflect the signal to the people on the other side, or satellite-based connectivity. Coming up with some satellite configuration, something between LEO and MEO kind of stuff that would be reasonably optimal, not just have this train of satellites, LEO, that's, it may be hard to manage that as well. So for India, what can we do? What satellite configuration can we do? So, and then that's where the heterogeneous networking would come in as well to provide connectivity and smart services.
Any other questions?
Right.
Okay. Let us thank Dr. Krishnaswamy.
Thank you.
Okay, so that concludes our afternoon joint keynote session across the multiple workshops. Now I'll invite first Professor Sajal Das to recognize Dr. Dilip Krishnaswamy with the memento. And where is Dr. Kiran Kuchi? Professor Kuchi?
So he stepped out.
Oh, he's coming back?
Yeah, he's come back.
Okay. Let's first recognize Dr. Krishnaswamy.
Okay, sir. Thank you.
Thank you. It was an honor.
We have to recognize Professor Kuchi as well, but I don't see him in the audience. Later you do it. Okay, so probably that concludes our session. And we have the next session for the society workshop, right? So you can take it
And we
over.
also have the parallel session, the tutorial and the MLBSS workshop. So you can just also
Come. Make all the announcement. Yeah.
So, we would also like to acknowledge the workshop organizers. So we had 3 workshops today: Society, MLBSS, and Icdcn. So I would first request to come Dr. Jaideep Howladar and Dr. Sujay Saha on the stage. who have organizing the society workshop. Dr. Ajay Pratap from the MLBSS workshop. Dr. Shravani Kundu for the Icdcn workshop, if you are here. Okay, I think she's not here, so we can move ahead with the next set of programs. We are going to have the tutorial along with these two workshops, which will continue, the society workshop and MLBSS. So let's move to the respective event. Thank you. So we have a break right now. So we have the tea break. So after that, we'll move to the workshops and the tutorial. Okay, so we continue with the session. So after the first session, we have the tea break. Professor Kiran Kuchi is here. So on behalf of the Icdcn organizing committee, we thank him for the keynote speech and want to recognize with a memento. So Professor Sajal Das. So we continue with the session.
Hello. So, so we are going to continue our second technical session, and this session will be chaired by Dr. Sujay Shah. Sujay Shah is a faculty from Computer Science Department of NIT Durgapur. In this session, we are having 3 papers, and the 3 papers are non-fragile token, a symmetric study of trust criteria. The second one is the faster convergence of adaptive data rate in dynamic LoRa-based IoT network application. And the final one is the optimizing autonomous intersections control using single agent reinforcement learning. So the authors of this paper are requested to come here and upload their presentations so that we can continue the session. Faster convergence of adaptive data rate in dynamic LoRa-based IoT network applications.
out of this kind of coins because young guys are buying that. Now, before I start off, I'll give you a very simple example of non-fungible token. Non-fungible token is somewhat like a young guy showing somebody that I have got a beautiful painting. Think about a very rich person. He buys an Andy Warhol, he buys a Monet and puts it in his wall. And then a guest comes in and he sees that there's a picture of Andy Warhol. And he shows that I am a rich person. Similar to the young guys who doesn't have money, how do they show that they are socially very powerful? So what they do is, they buy a NFT like a or maybe a penguin, and they put it into their social media circles. That I have a board yacht club number 212. So NFTs are nothing but digital arts stored in a distributed network, which can verify who is owning it and what are the characteristics of the particular NFT. So it's very new thing. It's only seen by or used by very young guys. The owner of them are more or less 17 to 25. And these guys show their social class that they own 3 NFTs of Bored Ape Yacht Club. They have 2 NFTs of Pengu or Penguins. So this is how NFT is working, and it's totally different ball game and different social class and different kind of asset class which people are working on. So I talked about NFT is nothing but a distributed network storage data of a particular item, which could be physical item, which could be digital item. And through distributed storage of network data, you can verify who is owning it. So NFT is nothing but a pointed code to a particular physical or digital art, which can verify who is owning it. In terms of, if you see distributed kind of computing, distributed network, one of the biggest use cases are blockchain and blockchain-based tokens. NFT is one of them, which is non-fungible token. Now, NFT was very kind of very trendy in 2021 when the market went up to $20 billion. Suddenly, because the blockchain market went down, the NFTs were not in kind of that kind of trendy. But just about 6 months back, blockchain and the crypto market is going up, and NFT is also coming up. So NFT market just this quarter is $2.1 billion from last quarter last year $1.5 billion. So the market is going very up, and we are seeing a lot of these new NFTs coming up. They are being minted, people are owning it, people are showing it. So NFT is something which is very interesting as an asset class, but the problem with NFT is that there is no way to kind of verify how good is this asset. Should I buy this asset or not? Think about when you buy a particular debt or a particular equity, ICRA or KI would give a rating. When you buy a stock, somebody will rate heading prospectus, somebody will rate it AAA plus. But NFT being such an important asset class and owned by the young guys who doesn't know anything about asset evaluation, they are all kind of, they buy just by whims and fancies and then they lose their money. So there is no framework of understanding how reliable an NFT is or non-fungible token is. And our goal of this research is trying to build up a framework so that a person can verify how good this NFT and whether he should buy it or not. So what we did was, we tried to understand the different variables. So as because there is not much of research papers around, because this is a very new topic, we try to understand what are the variables of verifying NFT or how good NFT is, writing down the variables, and then trying to understand from the surveys that what is the right variable for them, what is most important for them. And then we came out with a ranking-based approach. These are the most important variables people would normally look at while buying it. Or even when a company builds an NFT, these are the variables they should look at while building up an NFT. So that's examples out there. This is the Magic Eden. There's a new NFT marketplace doing very good nowadays. Currently now, this penguin, Pudgy Penguins, just got listed about 7 days back. It was listed at $7 million. And there's only limited number of NFTs which people bought and they bought and sold. And this is available in the marketplace. So this is where people buy and sell NFTs, but they just buy on the whims and fancies. good looking picture, good looking images, only one is out there, I will buy it. But is it by a right company, whether the contract is correct, whether the valuation is right? Those are not verified by these particular buyers. So for the whole research purpose, we try to understand the NFT landscape, and NFT in terms of Web3, there are different ecosystem partners, like somebody who issues the NFT, somebody who buys the NFT, somebody who does a security audit of the NFT. So there are different kind of stakeholders. So we try to understand the stakeholder, and from the stakeholders' business processes, we try to understand the different variables. Once we understood the different variables, we started asking the questions to this particular guys who has bought NFT at least once in the last 6 months or 1 year. Once we did the survey, we then did a topics analysis of a MCDM approach and ran the particular variables, 11 variables in total. So I'll very quickly run through these variables, because this is very important for us to understand. Authenticity is in blockchain. Whenever you write a code, and you can do in Ethereum or BSC or whatever blockchain Solana, when you write a code out here, you can verify who has written the code at what time and at what address the code was deployed. So authenticity is nothing but to understand that particular NFT was created by a particular person, and that particular person is the owner. That's the authenticity, that okay, I am buying from the right person. Transparency. Transparency is the way the NFT has moved across. Say for example, at Veggie Panguent, I am buying it, and then I sold it to somebody else. Whether there is a clear history of the whole buying and selling process. Is it transparent that this is being bought and sold at the right price? What is the commission given to the particular marketplace? What is the commission given to the guy who created the artwork? That's the transparency. Whether every money or every transaction can be verified. And also remember that this NFTs, because they are minted on a blockchain and they are sold across within a blockchain where a transaction is done, it has to be in a lower cost so that the minting fees are less, the transaction costs are less. How good the company is. For example, Bored Ape Yacht Club, one of the largest NFTs in the world, is from a company, Yoga Labs. Now, if Yoga Labs does another NFT, then it's good for them. There is a companies who does security audit. So, for example, NFTs can be rugged also. Rugged means that the money which is within the NFT, you can sell the NFT and take care of the money out. Whether the smart contract has the right kind of audit done, whether the functions are verified, those are done by who? By security auditors. So, if an NFT smart contract is audited, then it's good for us. Marketplace, even the marketplaces where you've seen that NFTs are listed, marketplace would also do KYC. They would also verify who is the person putting up the NFT. Whether he has some kind of financial irregularities earlier, something. So KYC will give you the financial irregularities as well. So somebody who is a kind of known as a financial irregular person, you can't take the NFTs and put it into the marketplace. Community feedback is very important, because community is all the young guys that are always in social media, Telegram, and all these places, Twitter, and they all talk in the morning, evening, every now and then. So community feedback is very important. Grievance management is very important. The other one was the community governance. So a lot of things is that the whole thing works in a friendly mode. There is no owner as such, but people will decide about what would be the next strategy be. Whether this NFT would be used in a game. If it is used in a game, what are the process of using that in a game? So the governance. So these are all owned by young guys who work together in a governance model, and based on the governance, the NFT value goes up because it's owned by everybody and decisions taken by everybody. There's something like utility and exclusivity I didn't talk about. Utility is what is the NFT used for? Can we use it for games? The exclusivity is that how many variations are out there. So if there are 100 variations and there are only 100 days can own that, that's the exclusivity of it. So these are the main variables we thought about, which could be important when you analyze a particular NFT before buying it. Even this could be the variables which somebody would look at before they create NFT. So for example, Yoga Labs, if they want to create NFT or penguins, they have to think about these variables when they create the NFTs. So we did a survey of 100 guys, 76 guys gave us the right responses. Demographics were mostly who has bought NFTs, has good knowledge of the NFT market. The sampling question was a like skill model of these variables in terms of their preferences, and we used Lobster's method to kind of rank the different variables together in a best case and worst case kind of the positive ideal and negative ideal, and how which is the best one and what is the ranking of them. These were the questionnaire samples. The result, we saw that everybody, I thought earlier was that the community is very important. People will kind of think about, okay, the social aspect of it. If we have an NFT, I'll own it. But we saw that authenticity and transparency is more important, because they said that if I know this NFT is being issued to the right company and I can verify that, I would probably buy it, because I know that my money won't be lost. If I know the transparency of the whole process of the NFT, how the NFT has moved across, what are the different commissions taken by different stakeholders, that's good for them, because they know that this is how the money is being spent. So the most two important things was that the building block of trust was authenticity and transparency. And obviously, if the cost was less, I will probably buy it, because when I sell it, I have to pay less. The middle part was the security part of it. So whether this particular NFT has security audit done, the security contracts have been verified, though the marketplace has verified the person who is putting up the NFT into the marketplace, those were the kind of security aspects of it which came in the middle. The last one was the community, utility and uniqueness. Those were important, but those were not going to take away money. Those were not going to kind of rug away and take away money. Those were good for us to show everybody else that I have bought this, but those came on the last. So the first one was that the authenticity or the bedrock of trust, then the verification of trust through security contract audited, and finally it was the social pride that I own the NFT. And that's the normal way probably every human being will think about while buying the NFT. So authenticity, the foundational blocks was the trust part of it. The middle part was the verification of this trust, and third part was that the fun part of I am owning NFT. The future of this work would be that if you can do an NFT-based scoring model about if an NFT can be scored about in these 11 variables, and there are a lot of new kind of NFTs coming up. If you can use those NFTs for different kind of use cases like a property or maybe a holiday house, those are now being sold as NFTs. Can we use those kind of different asset classes for these NFTs and do a valuation using these variables, or these variables have to change? And there's a new class of asset class coming which are called meme coins, which is like NFTs but lower in valuation. Whether we can use this for meme coins also. So those are the areas where we can move away with the future research. Yeah, I'm done. Any questions?
So any question? Question about copyright and ownership of NFT. If I create a piece of art, I always maintain the copyright, no matter who buys something.
So when you talk of physical art, so physical art you can create. Physical art is your art only, okay? But the physical art can be verified too well. You can fractionalize the physical art and give it to 10 guys. So it may be hanging in your wall, but you have sold it to 10 guys. With NFT, you can fractionalize them, and these 10 guys are the owners. That can be verified. That's one part of it. Second part of it is that, as because you are the owner, you can create a transaction within the blockchain saying that this is the transaction created by me, and this is I own. And the proof of the ownership is that okay, this is also in my particular wall. So one more person can do the same thing. He can take your picture of a wall and create that thing. There could be 5 copies of the same thing. But the person who has actually bought from you, he knows that the address ABCD was you, and he has bought it from you. So there could be copycats. Nobody can stop it. But there has to be the first one who did it. That verification can be done, and also now there are different ways of verification coming in terms of multi-signature. Okay. So if you have a particular hardware wallet, you can verify it. You can also now smart contract, you can do some OTP kind of verification also. Those kind of things are coming in. But as of now, people can copycat it. But the first person who had done it, and he has the proof that he's owning it, he is the owner of it. So normally when you create a company in blockchain, there will be 100 companies, copycats will come in, all scammers. But the first one who has the real business or the business model or the real NFTs or the real world, that gets the valuation done. Their token is being sold. Others companies' token are not being sold. So I have a meme coin. So once I did the meme coin, 10 companies came with the same meme coin, but they did not do the creativity, they did not do the storyline, they did not do the narrative because they wanted to make money out of it and run away. But people will see that okay, you have done it, you have been doing it for the last 3 months, you have done it, so you can verify in that.
So my point is that I own a copy of an art that was created by somebody, and someone makes an illegal copy of that. Illegal copy of that. So visually these two are identical. But only a proof will reveal which one is genuine and which one is fake.
Yes, so the guy who's owning it, he can create a signature on blockchain.
Yes.
And that is the verification that this guy is the real owner.
Yes. Okay.
Thank you, sir.
Sir, can you show us how NFT looks like and how can we authenticate it live? Can you show us the NFT and how can we authenticate it? Whether it's a
So I'll sit down with you separately, but normally the way is that you go to an NFT marketplace.
So what are those marketplaces?
Magic Eden, OpenSea, I'll give it to you. You'll see that when you put an NFT in marketplace, they will verify you. So the marketplace verifies whether you are the real owner of the NFT. Because you have to show that you are the first person who minted that. So the first transaction in the whole blockchain, 200 transactions, the first one is yours, and you have to verify that it is yours. And there could be people who's bought and sold it in 50 times, that doesn't matter. But you are the owner, or the last person who's the owner, he has to verify it. And he has uploaded that thing in OpenSea.
Is it legal in India?
There is nothing illegal in India, they have not said anything legal or illegal. It's like a technology as such. So, for example, use cases of buildings are coming up, which are not legal, not illegal, but you have to verify it through the rules of the land. So if you fractionalize a particular property, you have to fractionalize or you have to verify with the municipality of that particular country or that particular city.
Thank you.
Hello?
Yes, sorry, sir.
So there is a couple of questions. The first question is just to go beyond of Professor Ghosh said. So there is a copyright which can be protected. So we have a signature mechanism, and then we have a copy left scenario, where copy left scenario means I bought some NFT from different persons. Say I got some software codes from different authenticated person, and now I am the inventor or I am the deployer of a new system.
Okay.
And I am in the business. I am just a beginner of a new business where the previous things are already authenticated, and I am the new one who just gets the things as a copyleft, because copyleft is another licensing where it is open source in the scenario.
I don't know that.
So you will find that there is a kitty is one type of NFT. Kitty is a kitty, and then you can buy 2 kitties and create a new kitty, and you can be the owner of this kitty. So that is legal in the NFT. So in that case, how your system will verify? Because I don't have the history. I am the new one, and I just get some things from authenticated source, and I am came into the business. So
See, when you create say for example, there are different kind of scenarios where a mom and dad, 2 NFTs come out with the son, which is a new NFT. Okay, earlier games and all. Okay. So the son is a new NFT as such. That's what you're talking about. So I have not thought about that very clearly. But if it's a new NFT and you are the first guy who has inscribed it or put it in the blockchain, then you are the owner of it.
But my verifications is a doubt.
Because verification is that whether you had the moment at NFTs. Then only, the rule is that if you own the moment at NFTs, then only you can remint it or something like that. Rebirth it, okay, for games and all. So basically, there has to be some kind. I do not know the exact answer, but that matching of this particular two NFTs to create a new NFTs, that transaction, which is a kind of a if you call it pre-mint transaction, that has to be verified.
Means a new system may be designed, which is not in your proposal that you will maybe think of.
I have to think about that. But this is a very normal use case. This
is very normal in the
moment
software
that
design.
two kitties are playing around and a new kitty has come up.
Yes.
Yeah.
And my second question is that your survey is on the non-fungible tokens like ERC20 or something like that. And
ERC20 is fungible token.
ERC721. And ERC20 is a non-fungible. So
ERC20 is fungible.
Okay, ERC20 is
non-fungible.
So your survey or your all these things is on the non-fungible. So have you done these things on, or do you have any plan on the fungible, or is there anything?
Fungible token you cannot do this kind of ownership verification.
Okay.
Because all it's like a one Bitcoin. Both of it is same in our pockets. So like a Bitcoin. There is no proof that you and I they're two separate Bitcoin or two separate ethers. But NFTs they have a separate address and separate verification process. So for normal tokens, like meme tokens, meme is not an NFT. So this characteristic or variables may not work fully in memes. Memes are normal ERC20 token or whatever the EVM20 tokens.
So EVM fungibles are not required in that.
Fungibles is kind of lower value. NFTs is a pure use case of mapping of asset classes, physical or digital. And that's why the verification is important because the money is higher.
Or it may be increased in future.
Because say for example, say one Pengu token is around 30 ether, which is around $6,000. Okay, but one token, maybe one small token, what polygon, it could be $5. So it doesn't matter for the verification. But for that large kind of NFT, which is high value, the verification becomes more important. Think about a larger size thing.
Okay, fine. Thank you.
Thank you. So next paper is faster convergence of adaptive data rate in dynamic LoRa-based IoT network applications.
Good afternoon, everyone. I'm Alekia. I'm currently pursuing research in Pittsburgh Hyderabad campus under the supervision of Professor Dikumani Chaudhary. I'm honored to be here in IIT Hyderabad. Is a leading institute with significantly contributing to advancements in IoT and networking. Today I'm going to discuss our research on faster convergence of adaptive data rate in dynamic LoRa-based IoT network applications. I look forward to sharing insights and engaging in discussions with all of you. Today, I am going to discuss on the following topics: introduction, motivation, objective, and the proposed Trafocon approach, experimental setup, results, conclusion, followed with the references. Coming to the introduction, IoT, as we all know, is a technology which allows the devices to generate associated data and transfer them over a communication network. To support IoT's vast range of applications, we need a way to connect devices to the network which will do infrequent transmissions, but it should cover long range. That's where LoRa comes into picture. LoRaWAN is a communication protocol that functions on LoRa, which is capable to securely connect the devices to the network server in order to transfer data to the end user. This picture compares different wireless communication technologies based on their data rate and range. Here, coming to the first one, short range wireless communication, the technologies includes like NFC, Zigbee, Bluetooth, Wi-Fi, which will give us high data rate but with a shorter range. Here, this covers up to tens of meters, few meters to tens of meters. When coming to cellular communication, this gives moderate to high data rate when compared with short range wireless communication. This covers up to several meters. So here the technologies includes like 2G, 3G, 4G and 5G. Coming to the low power WAN technologies, the technologies includes like LoRa, Sigfox and NB-IoT. These technologies are ideal for the solutions for the devices which will do infrequent transmissions and which needs to conserve their battery power. So this technology is optimal for those IoT sensors. Here, this covers up to several hundreds of meters. Coming to the LoRaWAN basic architecture, the main components are end devices, gateway and the network server. Here, end devices are the sensors which will send LoRa signals to the gateway and receives back from the gateway. Gateway is one which will be mediator between the end devices and network server, which will receive and forward back to the network server and gateway end devices, vice versa. Network server is a piece of software that runs on the server which manages its entire network. Here, end devices and gateway are connected via LoRa signals, whereas the gateway and the network server are connected via standard internet protocols. Here, whenever end devices, like end devices are the sensors, example temperature sensors, humidity sensors, gas sensors. These sensors, whenever they have data, they will send data to the gateway which are within the range. So then the gateway work is to transfer the data to the network server. If network server receives multiple copies of data, then the network server work is to remove the duplicates and maintain single copy of a packet. Here, ADR is one of the mechanism which is released by the LoRaWAN specification itself. Here, ADR is a technique where it optimizes the time on a data rate and energy consumption. It's a built-in feature of LoRaWAN. It's a specified algorithm given by the specification of LoRa. Here, ADR will work on autonomous adjustments of some parameters which are very crucial. The parameters are transmission power, spreading factor. Here, spreading factor is a mechanism where the signal is going to spread across the entire bandwidth. Here, LoRa supports spreading factors from SF7 to SF12. These are standard specifications which we require when definitely to assign to the end devices by the network server whenever the devices have to transmit the data to the network server. Here, transmission power is the power where the devices are using to transmit the data from source to the destination. Whereas the spreading factor, like I said, it's a if you observe this picture, spreading factors, these are from SF7 to SF12. Here, this first one as SF7 spreads the signal less when compared with the SF12. Means here higher SF results in higher data rate but with a lower range. Here SF12 gives us lower data rate but with a longer range. Whenever we want to transfer data to the network server which is very far, then the device have to use SF12 because of the reachability issues. So here, as network server, this is the basic LoRaWAN network topology. Here we have multiple end devices. These are connected to the gateway and the messages from end devices are transmitted to the network server. Here, if you observe, this is the end device which is very nearer to the gateway. So this has to be assigned SF7 because it is very nearer to the gateway. So whereas this end device is very far from the gateway, because of the reachability issues, this end device must use SF10 to SF12, 10, 11 or 12, depend on the link quality as well as the obstacles what it is currently facing at that particular channel. So here, coming to the motivation, as area will work on autonomous adjustments of spreading factor and transmission power for each and every individual device which is requested every time, there are several challenges exist that limit its performance, like slow conversions, individual ascending SF and TP, so this leads to increasing latency. So several existing area techniques, as discussed in several studies by Khan and other researchers, fail to adapt they are limited to adapt the different network topologies as well as varying channel traffic conditions. Hence, our research proposes a novel CAD-based channel traffic estimation method which will enhance the convergence faster for the network, as well as it will ensure the data reliability efficiently transmitting even in dense and dynamic IoT environments. Coming to the objective, this novel CAD-based channel traffic estimation approach is designed to improve the adaptability of all the parameters like SF and TP, as well as increasing the ADI performance, like improving network reliability, minimizing the packet loss, minimizing the collisions. So, reliable data transmission across the entire densely populated IoT environment. Coming to the contributions of our work, we have come across with two contributions. The first one is channel traffic estimation and flag assignment. The second advancement is backup transmission queue mechanism. Coming to the channel traffic analysis, we developed a method to analyze the channel activity, as well as based on the channel activity, how the channel is, what is the current state of the channel, whether it is active or idle. Based on the channel condition, we are assigning either wait or transmit flag to the devices to transmit the data for efficient transmissions. Whereas this ensures that end devices will use the channel whenever the channel is less congested. So which reduces the likelihood of collisions. If every end device is sending data when the channel is busy, definitely every packet of end device may affect with the collisions and leads to retransmissions. So this will further reduce the collisions. The other approach is to further mitigate the collisions. We developed a backup transmission queue mechanism where we are giving end devices to the transmission queue. Based on the priority wise, we are assigning the end devices the parameters to enhance the convergence faster. Coming to the convergence, what is convergence? Why this is the biggest challenge in ADR in LoRaWAN networks is slow convergence is a condition where there is a delay in adapting the SF and TP parameters of the end device to get the optimal parameters for efficient communication. Here, we are using a technique called CAD, that is channel activity detection. Here, Semtech integrated CAD, which enhances the communication protocols. CAD refers to channel activity detection. It is a mechanism where the device senses the channel whether it is idle or active based on the current network conditions. So, but this Semtech integrated this CAD mode within the end devices. So that the problem with integrating the CAD mode in end device is end devices are very less competitive as well as they are battery operated. The main intention or main objective is to conserve the power of end devices for long life. That's the reason these are the drawbacks what the current CAD approach in end devices is facing. The first one is high energy consumption of the small minor end device or a sensor. and limited accuracy in dense networks, increasing the latency, hidden node problems, as well as difficulty in detecting short transmissions. As these are IoT sensors, they will send very minute data, less packet data like temperature sensor, 20 bytes, 8 bytes or 13 bytes. So this difficulty in detecting short transmissions as well as the additional computational overhead. As end devices are not main powered and these are battery operated devices, the aim is to conserve the power of the end devices to give the long life. So coming to the proposed approach, we are leveraging the CAD approach, but instead of using this CAD method at the end device node, we are assigning a work to the network server, as server is the mains power and it is not battery operated and it is also computationally efficiency. We are assigning the complete work to the network server, instead of giving CAD mode, activating CAD mode to the end device. Here, whenever end device wants to transmit data to the network server, it requests the network server, can I send data? Then the network server work is to sense the channel, whether it is idle or active. Means whether it is congested with a fuse traffic or it is less congested. So based on this, network server will sense the channel. Based on it, it will assign the CAD flags. We are not using the CAD in end device part, we are using the CAD in network server side. So it will give CAD flag. We are using the CAD approach, but we are just leveraging the CAD approach. So here, if CAD flag is 1, that means wait. It is telling that the end device to wait. So then the end device will go to the back off mechanism. There is a maximum back off mechanism, maximum back off time. If this back off time exceeds, then the transmission is failed and finally it leads to the end. Whereas if T-back mechanism is less than maximum back off, then end device is going to transmit it to the transmission queue, where the queue, then for each and every end device we are assigning a priority. How we are assigning priority? There are so many end devices which are in a queue. So based on the maximum time left to reach to the max back off, which end device have left less time, that device is given a higher priority. In this way, we are reducing the collisions. We are reducing the failed transmissions. Here, if the CAD flag is 1, that is wait flag. If the CAD flag is 0, then end device is allowed to transmit data, but with the allocated SF, this SF also allocated with traffic on algorithm only. We will go to that in the next slide. So how it is allocating based on that, I will explain you. So the transmitted packet, this SF is allocated by the network server to the end device. So if after assigning the SF and sending the packet from end device to the network server, definitely end device will require acknowledgement that the packet has been successfully transmitted. So if acknowledgement is received, the transmission is done successfully. If it is not received, acknowledgement is not received, it's waiting. So then the transmission is failed. How it is failed? Based on this condition as number of retransmissions. If the number of retransmissions is less than the limit, then the end device will wait for certain time and it will again transmit the data with the same SF. If this condition met, that is number of retransmissions is greater than or equal to the limit is exceeded, number of retransmissions also done by the end device and the limit is exceeded, then it treated as failure transmission. Again, the end device have to follow the same process from the starting. Now, coming to the proposed approach, how the SF parameter is assigned by the network server. Here, the inputs are spreading factors we have given by the specification as 7 to 12, as well as end nodes with corresponding throughput, signal to noise ratio, and RSSI, receiver signal strength indicator. And here, psi SF is a threshold we are taking as 2/3 of the channel traffic level. Here, the contributions are, we are calculating the CTCI based on the throughput as well as SNR average and RSSI average. What is CTC? Channel traffic contribution of that particular end device for particular transmissions. Then after calculating the channel traffic contribution, the channel traffic level is calculated with the summation of this contribution for each and every end device which is using particular SF. So many end devices are there. Suppose there are 10 devices, there are only 3 devices which are using SF7. So we are calculating the channel traffic level of that particular SF which are used by the following end devices. Then after this, there is a threshold we are considering as 2/3. Here, first 33%. Here, this is the channel traffic level for that particular SF as a threshold. Here, 2/3 is 33% is first 33% is considered as low channel traffic level. Next 33% is considered as high channel, medium or average channel traffic level, and the last 33% is considered as high traffic level. So here we are calculating the CTLSF, and based on that CTLSF, channel traffic level of that particular SF, we are checking this condition with this threshold, that is less than ISF. If this condition met, means the channel traffic is less or average but not high, then we are asking the end device to go back to the back-off mechanism to enter into the transmission queue and transfer the data based on the priority based. Whereas if this condition is wrong, means CTLSF is greater than ISF, stating that the channel is currently undergoing high traffic, then we are assigning wait flag, that is cat flag, as 0, and the end device can transmit the data, but by increasing its SF if the SF is less than 12, because we have SF7 to SF12. Suppose right now end device is using SF8 and the channel traffic is very high, then we are asking the end device to increase its SF and try to transmit the data. So definitely, because of the time on air, as SF7 to SF12 time on air is increasing, definitely SF8 packet is not reached. So SF9 packet will be definitely reached by the network server for the efficient communication. So this is how the proposed traffic on approach will work. These are the experimental setups. We have done the experiments on NS3 simulation. The number of end devices chosen as 400. The duty cycle is 1%. Packet length is 20 bytes. As these are free sensor devices, we are using 20 bytes minimum data. And preamble length is 8 bytes. Frequency that LoRa supports is 865 to 868 MHz. So we have used 868 MHz. Bandwidth is 125. Coding rate is 4/5. For every 4 bit of data, the 5th bit is a redundant bit which will correct which is used for error corrections. Whereas here path loss exponent is 4. As we are experimenting, this is an exponent where because of the shadowing effect or the obstacles, the devices may not able to listen to the network server or the gateway. That's the reason the specification has given some values which we have to use for the path loss values. These are the spreading factors from 7 to 12, and the transmission power for that small sensors is, we are supposed to use 2 to 14 dBm. These are the results what we have done. We have compared our traffic-on approach with CA-ADR, Explorer, LoRa, LR, and the standard ADR, which is the LoRaWAN specification released algorithm. Here we have used 400 as a network size, and channel traffic total packets per minute is increased, and we have got the good results when compared with the several standard ADR algorithms as well as existing ADR approaches. Coming to the conclusion, this paper introduces the traffic-on algorithm, which leverages the CAD-based channel traffic estimation approach. Instead of allowing the end device to sense the channel and let it decide whether to transmit or not, the network server is taking all the headache, as it is computationally effective and it is mains powered. It will sense the channel and it will assign wait or transmit flag to the end devices. So this definitely reduces the collisions as well as improve the network convergence faster and gives the efficient communication in reliably sending the data to the network server, even in densely and dynamic populated environment. Like IoT, there are different heterogeneous environments are there, end devices are there. Even in that densely populated environment also, we are able to transmit the data successfully. The future work includes, as we have included only static end devices, like temperature sensor, humidity sensor, we are trying to work this approach for mobile devices like pet tracking, asset monitoring, wearable wristwatches. These are the mobile devices. So we are trying to extend this traffic on to mobile devices as well, and also scaling the test bed to validate these simulation results. These are the references. Thank you so much for your cooperation. Thank you.
Thank you. So any questions? Okay, so how to implement this mechanism in real-time devices? Is there any idea?
Yes, we are currently working on the test bed as well, but this algorithm has not been tested. So here, this approach, we are integrating the LoRa end devices like ESP32 module, and we are flashing the code through the devices via Raspberry Pi gateway.
But this is the back layer based protocol, na? So how
Yeah.
to incorporate this back layer mechanism in hardware? That
We
I'm
have
asking.
We have church stack environment where we have a dashboard where we can directly flash the code to the end devices, and we can check the real-time values as well.
Okay, so it is the NS3 simulator. In real time, there's a noise, na? Is there any noise model you have added?
NS3, why we are using is it has some complex compatibility.
My question is, any noise model you have incorporated when you are emulated these things?
Yes, there are inbuilt Python models. If we are integrating some relay devices, there is one another module for NS3. So directly integrating those modules and libraries, we are flashing the code and we are checking the values.
I have a question. So in your you mentioned that the network server senses the channel and takes the decision. So in a LoRa setup, there are senders and there are receivers. So in a practical LoRa setup, which device will be the network server and how will it sense the channel?
Network server is just a chirp stack server, which is a dashboard where we can simply install the software on our laptop, as well as we have end devices which are temperature or humidity sensors. We are connecting end devices and gateway via RF signals which don't have any connection, and this gateway and network server is connected via internet protocols. So whenever end device is transmitting data, the network server will senses the nearby devices based on the RSSI and SNR values. Because initially end devices will transmit the data 10 packets end devices will send. Based on those 10 packets only, the network server will sense by doing channel traffic contributions. Thank you so much.
Okay, thank you. So the last paper is optimizing autonomous intersection control using single agent reinforcement learning.
PCR or switch off?
So good afternoon to all of you. I am Nitesh and I am presenting the topic optimizing autonomous intersection control using single agent reinforcement learning. So on behalf of Yes Ganal, Vinay Kumar, Sadhar Dulare, Ramnayan Yadav, actually due to some severe challenges they are not able to present today. So I am just giving the brief introduction about this work on behalf of them. So you will face, if you find any query or any doubt, you can simply mail to @iitram.ac.in to any of them and they will reply you. So these are the overview. And actually what they have done, they are basically solve the challenges of the automation intersection management. Actually this problem solve the, what I can say, the traffic congestion, and by using the reinforcement learning they are able to solve these challenges. Actually they have compared the two algorithms. We will discuss about that, how they have compared these two algorithms, and based on that they are getting the result, and based on that they have defined that okay, they are able to solve these challenges. So actually they have proposed the two autonomous intersection management algorithm, that is the PPO and A2C, proximal policy optimization and advantage tracking. And additionally, they have added the reward scenario to increase the throughput. So based on these three functionalities, they have solved the autonomous intersection management problems. So these are the reinforcement learning algorithm components. So state space, action space, rewards. So on the state space, they simply put the space state like what are the vehicle current conditions, and based on that they have taken the actions like how the vehicle will move from the direction or go to a nearest of the junction based on this action space. And after that, they have formalized the rewards, and based on that rewards, after all these three components, they have taken the decision that, okay, these are the autonomous intersection conditions. So here you can say this is the reinforcement learning state space. Based on this space, means these are the some like the traffic intersection with multiple lane and direction, including state left and right. Actually, the problem is that how it is happening, why these challenges occur. The problem is that the vehicle is normally not taking only the vehicle to vehicle communications. They are taking the vehicle to actions, the vehicle to everything. So they are taking the information from all this scenario, and based on that they are taking the decisions that how they will move. So that's why they have taken the reinforcement learning approach, this PPU and A2C. And here these are the reward scenario in which they have given some marks or given some numbers to the based on some parameters. Like for the collision, they have given the negative marks, and for the highest speed and the vehicle is arrived on the road and off the road, they are giving some parameters, and these values they have got based on some simulation framework. So these are the two algorithms. And after that, these algorithms have been simulated on the smarts and the sumo, and they have used the Python code. These are the results, and here this is the simulation and result in which they have mentioned that this A2C algorithm performs better in terms of the average reward and the maximum reward, but in terms of the collision, the PPO performs the better scenario. So it depends on the applications. If they are going for the collision domain, so obviously they will prefer the PPO reinforcement learning algorithm, and if they will go for the reverse scenario, they will follow the A2C algorithms. So these are the conclusion. Actually, they have basically compared these two algorithms, A2C and the PPO, and based on that, they have mentioned that if the applications needed the reward functionality, they will go for this A2C platform, and otherwise they will go for the PPO. So these are the references. Thank you.
So, okay.
Question?
Okay, no problem. Okay, thank you. Okay. So I'll hand over to the Joydeepta for best paper for the workshop, society workshop.
So this is the last part of our workshop program. We have a best paper award, and with the decisions of the session chairs, it was decided that the paper secure and expressive authorized keyword search in cloud-assisted cyber physical system is awarded as the best paper. So congratulations to Kosturi and Padalochon from IIT Bhubaneswar. I request Ms. Kosturi to receive the best paper award from Professor Nirmal Roy. So please, Nirmal sir, honor the best paper.
Change PCR. Okay, okay. Okay, done, sir, done.
Yeah.
Sir, come. Bro.
A little request from the audience. So I request all the audience to be on the stage so that we have a group photo. Uh, all those who are present in the hall, please have a group photo. Sir, and in the meantime, I would like to express our heartily thanks to the IIT Hyderabad for providing us this opportunity to host the workshop in the Icdcn 26th International Conference. So we have got a good venue for organizing these things, and we also express our thanks to the organizing chairs and those who have supported us throughout the programs. So hope we will meet in the next year. We are planning to have also continue this session for the next in the sequence. So thank you.
ల్యాప్టాప్ పట్టుకో సార్ ల్యాప్టాప్ పట్టుకుంటా తీరం కదా పట్టుకో ల్యాప్టాప్ పట్టుకుంటా అయిపోయిందిలే కానీ ముందుకెళ్ళి ఒక ఇక్కడ నుండి వస్తుందంట సరేలే ఉండండి ఎక్కడ ఉన్నాను ఇంకెవరు రావాలా నోయల్
ఎప్పుడు అట్లా పెట్టలేదు లైవ్ స్ట్రీమింగ్ వచ్చిన ఇన్ని సంవత్సరాలు నాకు ఇప్పుడు అప్పుడు ఐడియా వచ్చిన అట్లా పెట్టాలి ఇదంతా ఫోటో
Noel, wait, sir. Hey, Noel, come back. Okay.
So thank you all of you for your presence. The organizers has informed that certificates will be online, so the certificates will be mailed to you. So otherwise you knock us, we will try to arrange the certificates.
Noel, wait, sir. Hey, Noel, come back.
మీరు కూడా చేస్తారు మీరు కూడా లేదు నాకు ఇంకో I wanted to meet somewhere, but maybe I will not షోరూమ్ లో కొన్నా షోరూమ్ లో ఇక్కడ సెంటర్ నెక్సస్ మాల్లో సెంటర్ ఉండేది కదా సి మీద థర్డ్ ఫ్లోర్ సెంటర్ మళ్ళీ